In this lesson, you'll learn how to code an Android service, including the interface to the service component and the service component itself. We'll use a sample app as shown here, it's called Service Example, to demonstrate the service. The app is included in the Working File Samples workspace. I suggest you watch this lesson first, then open the app yourself and run it in the emulator as I'm showing here. I also suggest you print the graphics from the services concepts lesson to have them to refer to as we explore the services code. It's easy to get lost in the details of the code, and the graphics will help you understand how all the pieces fit together. So in Eclipse, let's first look at some of the resources. Let's maximize this, and let's take a look at strings. In the strings XML file, we've defined the text you'll see in the display. In the dimensions XML file, we have sizes for the text. Restore this. Go down here, double-click on the layout. In the main layout XML, we have a linear layout for our screen display with a field for the header, the buttons, and the text at the bottom here. In the manifest, notice the declaration for a service down here that uses the service tag and the name of the class that will be executed. Now on to the Java code itself. First, we'll look at the service interface. Before we do this, let me just run the app real quickly so you can see again how it works. When we click Start Service, we get a toast of service started and the message service running, and then the toast service message that's being generated by the service itself. And if we click Stop Service, we get the toast that the service is stopped and the message service not running. So in the service interface code, which is controlling the user interface we're seeing here, we have the package name, the imports, and the activity class named service interface. We define the onCreate method with the setContentView to establish our initial layout, and we define variables for our start and stop buttons. We set on-click listeners for our buttons. And so far, all the elements we've looked at in the app, we've seen a number of times in previous lessons. But now we're really starting to build on previously addressed topics. So if you need to, please pause the course and review any previous lessons you need to. The next couple of statements here are new for us. They define a text view variable for accessing the service running, service not running text shown here in the display, and they initialize it at service not running. And we'll be studying more about text view and the user interface in a future lesson. Next is the on-click listener definition for the start button. And in it, we use an explicit intent to start the service, specifying the class name of our service execution class. Then we have another set of the text view and set text statements that display the text service running. I'll show you that. So there it is. Next is the on-click listener definition for the stop button, which is almost the same as the start button, except it's executing a stop service and displaying the text service not running. Click the stop button. There you see it. So that's our service interface activity. Now let's look at the service execution code. In the service execution code, we have our package name, our imports, and in the imports, notice the inclusion of the handler, handler thread, iBinder, looper, message, and these are classes we'll need for our service component. Next is an instruction to the compiler to ignore a handler leak error message. If I comment this statement out and save it, we see an error message appear here, which says this handler class should be static or leaks might occur. Well, I tried making it static. I tried a whole bunch of things, and there is no solution that doesn't produce other error messages. So what I did is I included this suppression, uncomment that, and save it. You see the error has gone away. So this error is really just a warning that we could get a memory leak, which we're not going to have. and there's no solution to that error message. So we'll just leave it the way we have it by suppressing the leak message. And you might see this from time to time, so you know that this is one way to avoid having that error message appear. Moving on, we have the definition of our service component, which is named service execution. First, we have definitions for a looper variable and service handler variable. Next, we have a definition of a handler for our service, which we're calling service handler. And this is the class that will handle our service messages and do the real work of the service. First is a declaration of the constructor for the class, which is executed once when the handler object is first created in response to starting the service. This super looper statement is overriding the superclass parameter to use the looper we provided it when it's created, which we'll see below in the onCreate method. It's a little confusing, I know. Consulting the graphics we looked at should help understand all of this. Next, we have the real heart of the service, the handle message method. This method is invoked when a message is created in the onStart command method, which we'll see in a moment. And this is where you would place your app-specific code for the service. In our sample, we're just sleeping the thread and displaying the text service message. So we can see that if we come back over to the emulator, click Start Service, you see service started. Now you see service message. That's coming from right here. So that lets us know that our service has in fact kicked off and it's communicating with us. You can also use the stop self method if you have instances where you'd want the service to stop itself. For example, if it's having trouble accessing something on the internet or there's some kind of errors that take place where you want to stop the service. Next is the onBind method. And this is used if you're communicating directly with another process in a client-server type relationship. And we're not using the onBind capability in this app. Next is the onCreate method that's invoked when the service is first started. In this method, we create a background thread with a looper using the handler thread class. We start the thread and get the thread's looper, and then we create a service handler object using that looper. So this is where you really need the graphics to get a good feel for how the looper is being passed around. Now, the first and subsequent times the service is started, the onStart command method is invoked. Here we first obtain a message from the message pool using the service handler. We then retrieve the start idea for the specific start and assign it as an argument for our message. Next, we send the message using the sendMessage method. This message is then picked up by our message handler method above. We then toast the service started text. Let's do that. It's running, so I'm going to stop it. We start it. We see that service started toast before the service message. That's coming from right here. And finally, we return a start sticky. What this means is if this services process is killed while it started, then the start sticky says leave it in the started state, but don't retain the delivered intent. Later, the system will try to recreate the service. Because it's in the started state, it will guarantee to call onStart command after creating the new service instance. That's very difficult to absorb, so you might want to research start sticky yourself to find out more about it. The final method that we've set up is onDestroy, and this is invoked when the service is stopped via a call to the stop service method. And what we're doing here is simply toasting service stopped. So if we go back over to the emulator and we click Stop Service, we see the service stopped toast appear. So that's it. If you were able to understand and absorb all that in the few minutes it took us to go through this lesson, you're one very efficient learner. What you might want to do is fire up Eclipse with the sample app and go through the code again while looking at the graphics. I think you'll be able to see how all the pieces fit together.